Hey everybody, welcome back. Hope you all had a good weekend and a good Labor Day. Um, Before we get started with the material this week, I wanted to talk about the quizzes and the assignments. There are not many, but a couple of you are still not submitted the week 3 quiz and the week 3 assignments at the time of the recording here. Uh, and even though there is a late penalty, there is, the late penalty actually does have a limitation. So remember this throughout the semester that even if you miss something, you can always go back and submit it late. Uh, and at least get some points for it. There's a deadline for when it's due, but there's no deadline for how long it'll be available to take submissions. So anything that's happened, you can submit late all the way through the end of the semester, and at least get some points for your efforts instead of none. Some is better than zero. And for submitting the assignments, some of you posted the assignments in the discussion board. In the course materials section, when you look at the assignment, the instructions show up in the list there. But if you actually click on the title of the assignment, it'll take you to a page where you can actually submit to the assignment directly there, and you don't have to put them up in the discussion board. And that would be, of course, my preferred way that you do it. So this week we're going to start talking. We're going to be talking more about the command line, and we'll be introducing you to some of the shell utilities. And we're hitting the command line, and we'll be talking about the command line basically the rest of the semester, because the command line is really the heart of managing Linux systems. Even on your own systems, you have the GUI desktop and all that, and utilities to manage everything. But in a lot of cases, the GUIs can be somewhat more limited than the command line tools, and especially when you get into managing more than one Unix box or Linux box, the command line is essential. It's just much easier and much faster to do things that way, especially managing multiple systems. And then there'll be reading in the Practical Guide to Linux Commands, Editors, and Shell Programming book, and of course a quiz and an assignment. So let's get into the command line. So this first part is a little bit of a review, of course. The command line, or CLI for command line interface, or shell. That is the text interface to a Linux system. It's accessed via a terminal, and that can be a terminal application in your desktop GUI. It can be a virtual terminal, switching from your GUI to a virtual terminal, or it can be just a direct terminal, and you can actually boot your Linux system up without the GUI at all and boot directly to a terminal. In a command line, of course, commands you type at the prompt are passed to your shell, and your shell handles them, passes them to utilities or to the kernel, in the case of shell built-ins, and then executes what it is you're trying to do. And then below there you'll see an example of a shell prompt. Yours may look slightly different, and those are very customizable. We may talk about that a little later on, but if you want different information in your shell prompt, you are certainly able to put almost anything you want there. And you'll see that the example prompt ends with a $sign. That is one of the customary endings of the prompt to let you know that that's the end of the prompt and where your input begins. And the $sign, or in some cases it's a %sign, indicates that it's a regular user shell. If you were to log in as the root user, the customary prompt for a root user is the $sign or the £sign. And some of the features of modern shells, and this is, I say modern shells because older Unix shells did not always have these, and some of the ones you can use now, like the old Bourne shell or the just regular SH, is missing some of these features. But with modern shells, you get things like history, where the shell tracks the last X number of commands that you have run, and that X is configurable, so it can be anywhere from just a few to hundreds. And so it'll track the commands that you've run, and then you can go back through that list. So if you're working on something and you're typing very complicated commands, you don't have to remember them or type them over and over again. You can just scroll through your history list or choose one of the items from your history and run it again directly from there. All shells, even the older ones, are scriptable, which means that you can write You can automate things with your shell. You write a simple text file with shell commands, and your shell will run that just as if you're typing everything on the command line. They feature aliases, so you can take a long, complicated command, or even just something that you type frequently, and you don't want to type so many characters. You can alias them down to very short little. You can alias one letter to a command. And then variables. This goes along with scripting, so you can set variables in the shell for your shell scripting or programming, or the shell features what is called environment variables. So when you log in, your shell sets a bunch of variables that that contain things like where your home directory is, what shell you're running, some various preferences and things like that. And we'll look at some of those in a bit. So running a command in a shell follows a basic format. You run, you type in the name of the command you're running, and then any options that you want to give to that command, and then any arguments. And options and arguments differ slightly in that options change the behavior of the command, and arguments provide information to the command. So in the case of the ls command, if you type ls-al, ls is the command, -al is the argument, is the option to the command, and that's A for all, so it shows all files, even those beginning with dots, and L for a long listing, so it shows you more information about the files rather than just the file names. And then the argument is /var/log. So you're telling the ls command to do a long listing with all files for the directory /var/log. So we'll take a quick look at that. So if I'm sitting in a directory under my home directory called CS41, if I just do, I'm actually going to go back to my home directory, so I'll just do cd to go to my home directory. And if I just do ls with no arguments, it just lists all the files and directories that are basically not hidden. And not hidden means not starting with a dot. So if I do ls and I give it the A option, that shows me all of the files, including the ones that start with dots. And then if I do ls and then give it two options, al, it shows me all of the files, including those that start with dots, in a long listing format, which gives me the permissions on the file, the owner, the group, the size of the file, and its last modified date. And then if I run the command again, and this time give it an argument, /var/log, it gives me the same kind of listing, but in the var log directory and instead of my home directory. Now the options are specific to each command. Each command has its own options that it wants or uses, and typically you can find those on the help screen for the commands. Most commands will take the -h or --help option, and we'll give you a brief little help screen on how to use the command. Or you can read the man page for it. And then there are two basic formats for the way that commands take options. There's the traditional Unix format, which is a single dash and a single letter for the option. So in the case that we were looking at before, the ls command, -a is an option, -l is an option. And those are, there's one dash and a single letter. And with traditional options like that, they can be grouped. So -latr, you wouldn't have to type -l, -a, -t, -r. You could, but you don't have to. You can just type -latr. And then there's the GNU format for options, which is a little more typing, but is a little more explicit, a little more readable. In that instead of -a in the GNU format, it would be --all. And the GNU format starts with two dashes and then a word for the option instead of just a single letter. And many commands, you'll notice if you look at man pages or help screens, will take options in both formats. In some cases, they'll take an either/or, so you could type -a or -al and get the same effect from the option. And in some cases, they'll take some options in traditional formats or GNU format, and some options only in the GNU format with the --, and then a word. So the shell does keep a history, modern shells anyway, to keep a history of the commands that you've typed. And that, of course, would be pretty useless without being able to look at that list and use that list. So they provide a command called history. History is actually a built-in alias for a command called fc. So when you type history, you're actually running an alias or the equivalent of the fc command with the -l options for lists. So that will give you the history in a list. And those commands are interchangeable. History is generally easier to remember when you're thinking about that kind of thing, but you're certainly able to and welcome to type fc-l to look at the history. They are, exactly the same command. And then most shells will take the arrow keys for command line history. So if you're sitting at a blank shell prompt, you can press the up arrow to look at the command you just ran previously, and then you can keep hitting the up arrow to scroll backwards through your command history. And then once you have a command on your command line that you want to use, if you want to change it, you can use the left and right arrows to move the cursor back and forth in the command and make changes to it. And then there's a shortcut for running previous commands, and you can use the special character, the exclamation point or bang character, to run commands from your history. So you can use the bang and then a number, and then your shell will run the command in your history with that line number. Or you can use two bangs, which will run the last run command. So if you run a command and you want to run it again immediately, you can use two bangs to do that. And it also does a rough search kind of thing. So you can do bang and then the start of a command, and your shell will go backwards through your list of commands, starting with the most recent and keep going back until it finds the first command that matches the first characters you type there, and then it reruns that command. So let's take a look at that. And see if so I'll type history here, and to look at the list of commands, the most recent list of commands I've run. And it shows a brief list. You can see that it's saved 117 commands that I've typed so far, but it just shows the last few. And just to show, I'll type fc-l and run that command. And you can see that it's exactly the same command. And one of the nice things about the history command or the fc command is that it doesn't track itself in the history. So you can type history and look at the commands, and then if you want to look at it again right away, you can type history, and the history command itself won't show up in the list. So now say I've got my list there, and I want to run, let's say, command 106, which is the cd to the var log directory. I want to run that again. So I can type bang and then 106, and you can see that it puts up the command that it ran. Did cd to /var/log, and there I am. And then, so I just ran the pwd command, and say I want to run that again right away for whatever reason. I can just do two bangs, and you can see that runs the pwd command and prints the current directory I'm in. Now say I want to go back and run the let's see, the first the most recent cd command that I've run. Let's say that's not a good example. Say the most recent man command that I've run that's in the list there. So if I type bang and then man, it runs the man command, and I was looking at the ZSH built-ins man page, and it runs that again for me. We've touched on shell variables a little bit in some of the past weeks. In the assignment for last week, one of the ways you can look at the name of the shell you're running is with the $0 variable, and the $0 variable always contains the name of the executable that you're running. And in the case of sitting in a shell prompt, when you echo $0, that's going to be the name of the shell you're running. I also know that some of you are familiar with environment variables that the shell sets. Some of you in that exercise used the $shell environment variable to look at the name of the shell. A perfectly valid way of doing that, and that's good to know. But in addition to the built-in variables like $0 for the name of the executable and the shell environment variables, you can set any variable in the shell. So in your scripting or when you're working with something and you want to track something, or I use it a lot for if I'm doing something where I'm moving a lot of things around and and I want to like test things in a directory with a long file path. I might set a variable, to a single letter for that long file path, so I don't have to just keep typing that long string over and over again. So the command shell variables can be viewed using the echo command. So you can echo a shell variable like $hist size here, and that will show you the value of that variable. And you can modify variables just by setting them to a new value. So in this example, hist size equals 500 will change the value of the hist size variable to 500. Keep in mind that any variables you set, including environment variables, when you change their values, those changes are temporary. They only last as long as your shell session. So when you log out or you quit that shell or you close that terminal window, all of those changes are gone. You can make them permanent, though, by putting them in one of your configuration files, like your .bashrc, your .zshrc, or your .zshenv. In the case of environment variables, you just traditionally and for clarity, you'd put them in the .zshenv instead of .zshrc, although they will work being set in either one. So let's take a look at some of the variables. As you saw from last week, if I echo $0, that's the name of the executable I'm running, so that returns ZSH. I can use the env command, which is short for environment, to list all of the shell environment variables that are set. If you want to look at the value of a single one, you do echo, and then the name of the variable would proceed with a $sign. So then it echoes bin ZSH, which is the value of the shell variable. You can also do echo $home for where your home directory is, or in the case of the example in the slide, echo hist size. And the hist size variable here contains the size of your history. That will be the number of commands that your shell will save in your history. And if you look at the list there, you can see that there's also a save hist environment variable with a slightly different number. And the save hist command, or the save hist variable, that value is actually the number of lines that will be saved in your hist file, which is the variable one above hist size. So I have a .zsh.history file in my home directory, and every time I exit a shell, the shell saves the last 512 commands from its history buffer, which is slightly larger than that, but it saves those last 512 commands into my .zsh.history file, so that when I log back in, start a new shell, I have that history available to me right away. I don't have to type a whole bunch of commands again to build up a history list. And then again, as I said, you can set a variable for just about anything. So if I want to set v equals /var/log. Now if I do echo $v, it's /var/log, and then you can use that in commands because the shell will expand the variable basically anywhere. So I can do ls-al $v, and it expands that to /var/log and shows me the contents of that directory. And one of the more important variables, shell environment variables, is the path environment variable. And that would be accessed, of course, with $path. That's the environment variable that your shell uses to determine where commands can be executed from. So you'll notice, like when you're typing commands, you don't have to type a full path to some commands. You can just type the name of the command, and what your shell is doing is it's looking through all of the directories in your path in order until it finds the command that you're typing. and then it executes that command. If you try to run a command that's not in your path, you'll get a command not found error. But then if you have commands in a directory that's not in your current path, you can modify your path by adding directories to it. And sometimes you'll install a package that will tell you to modify your path, because it'll install, typically your path by default contains things like /userbin, /bin, maybe a bin directory in your home directory. But if you have a package that installs itself under, say, /opt, and its executables are there, sometimes it'll print a message telling you to add this to your path, and you can tack on directories to your path as you need, and then your shell will search through all of them to find the executable files. And sometimes it can be with a number of directories in different places where utilities and executable commands can live on a Unix and Linux system. It can be difficult to know, where that command really is, and so there's a command on the system called which that will search through your path and finds the command for you. So then it'll tell you, where in your path structure that command lives. And what it does is it does the same as when you're trying to run a command. It searches through your path list in order, and then it does that until it finds the command you're looking for and returns the full path to that command. Which means that if a command in a different variation lives in more than one directory, when you run the which command, it'll find the first one in the path structure that you have in your path variable and show you where that one is. So in my case here on my VirtualBox Linux system, I'm going to echo $path, and that shows me that my path is user local sbin, and then user local bin, and then user sbin, and then user bin, and then sbin, and then bin, and then user games, and then user local games. That's a pretty typical path. A lot of times when you do a default install on a Linux system, as a regular user, your path won't have the sbin directories, and the sbin directories differ from the regular bin directories in that the sbin directories typically contain system utilities or utilities that are meant to only be run by the root user, the super user utilities. In my case, I've modified the default path, which is everything, the user local bin, user bin, user games, user local games is a typical default path, and I've just stuck in the sbin versions of those into my path as well, because I'm a user, I'm an administrator, so I will be using sudo to run those commands, so I wanted them in my path. And to modify your path, you can see that the directories are separated by the colon character. So a simple way to add a directory onto your path is to just set your path and then equal to $path, which will expand to the current path, and then the colon to separate a directory name. And then let's say I want to add a bin directory in my home directory. So now if I echo the path, you can see that it's exactly the same path as before, but now with the addition of the new directory I just added to it on the end. And now say I want to try to find a command. So there's which to find commands in your path. So if I want to find the location of where the date command is, it tells me that the date command is located in bin/bin/date. Once when you start talking a lot about the directory structure and that, in a lot of cases people will just kind of leave out the slashes for really common directories. So bin is just assumed to be /bin, and user local bin is /user/local/bin. It's just a lot easier to say user local bin than include all the slashes when you're talking about it. And shell aliases, I guess, could be thought of as similar to shell variables. They, are a stand-in for, generally for a much longer a much longer command or that. So in that case, they're holding a value. But in the case of aliases, you can use them like commands. Instead of the variables, we use the $sign, and you can expand those variables in the arguments of commands and things like that. An alias is a shortcut to another command, and usually they're used for the command and a bunch of standard options that you like to use, that sort of thing, so that you don't have to keep typing these frequently used commands and all their options over and over again. And like shell variables and environment variables, aliases are temporary unless you add them to a configuration file like your .bashrc. And there is a command you use to view and set aliases. Aliases can't be set just by typing the name of the alias you want and then equals and the command you want to use. That would actually just set a shell variable. So there's the alias command to view and set aliases. So if you just type alias by itself, it'll show you the list of aliases that you have set. So you can see that, I like to run on the ls command with a default of -an as the options. But actually, if I take that back, let's go back one more. So I like to run the ls command, and I want to see color, and I want to see the tags for the slashes to denote directories, and the star character to denote executable files in my listing. So I've aliased the ls command to ls-f-color. So that shows me the little indicators, and it shows them all in color. And then generally I like to use the -an options with the L command as kind of a default. So I've gone one further and shortened ls, which you can see is actually ls-f-color. And then I've added the -an option, and I've aliased that to just L. So if I type ls here, you see it's showing me in color and with the little tags here, the little slashes after the directories. If I just type L, it shows me the ls in color with the slashes and all of that on the commands, or on the directories. But then it also adds the options A and N, so it shows me a different listing. But that's pretty handy. You type ls-al or ls-an a lot from the command line. So aliasing it to just L can actually save you a lot of keystrokes over time. So then to set a new alias, let's look at the aliases I have. So let's say I wanted to alias the which command. I'm spending a lot of time looking for commands, so I want to alias which to say just WH to shorten it up. You don't really want to shorten that all the way down to W, because there is actually a command that is just the letter W. So there is a W command that shows you users on the system. So I'm going to shorten it to just WH. So to do that, I would do alias, and then just like a variable, WH equals which. Now if I type WH, the which command requires an argument. So if I just type WH and then date, it tells me that date is /bin/date. So another set of special characters and expansions that the shell will do is called globbing, or wildcards. You've probably heard of wildcards in different things before. In Unix, it's been known as globbing, but it's the same basic idea, the same thing. For the shell, there are three basic forms that takes. There's the asterisk or the star, which matches 0 or more characters. So if you typed ls-al and then AB star, it would match anything that started with AB, whether for any number of characters, 0 or more after that. The question mark matches exactly one character. So if you typed AB $D and you had files named ABCD or ABDD, ABED, that $sign would match any character in the middle of A, B, and D, but only a single character. So if you got a file named A, B, C, E, F, or A, B, C, E, F, D, that $ wouldn't match that file because it matches exactly one character, and there's more than one character between the A, B, and the D. And then say you want to match a specific set of characters, a more limited range than just one of any or any character. You can put a set of characters in square brackets, and then the shell will match exactly one of the letters in that set of characters. So let's take a look at how some of that shell globbing works. So I've gone to my user bin directory. If I do an ls here, see that there's quite a number of files in the directory. So say I want to look at just all of the files in this directory that start with the letter L. So I can do ls-al and then L star. And then that shows me a list of just the files in this directory that start with the letter L. And of course you can do different variations on that. If I wanted to see all the files that start with LD, there's 4 of them. Say I want to find all of the files that start with L and end with, end with D. So, and you can see it, since it matches 0 or more letters, that L star D also matches just LD because there are 0 or more letters between the first and last character, which are LD. Now, if I wanted to match a specific number of characters, so let's say I want to match all of the commands that start with L and have exactly 4 letters in their name. So you can see there's not very many of them, but there are some. So there are a couple of nodes like that end with the T. So let's, if I want to find all of the 4-letter commands that start with L and end with T, that are exactly 4 letters, I could do that, and I get last and glue it. And then for the square brackets, let's say I want to find all of the commands that start with L, have any number of letters, and end with either A, B, or C. So last B starts with L, ends with B. Link ICC starts with L, ends in C. See, it found just a few commands there, and there's even one LZMA that starts with L and ends with A. So your shell will expand variables and special characters and the glob characters in that. But sometimes you want to run a command that you don't want to expand all of those variables or special characters. So there are ways to do that, and you do that generally with quoting. So you can use double quotes, which disables a few of the meta characters, but not all of them. And it still allows for variable interpolation. Sorry. So you can quote some of the characters. If the subset of characters that you don't want to interpolate are quoted with double quotes, and then you still want to expand your shell or environment variables, you can use double quotes to do that. If there is, say, a special character in that command that you don't want to expand to interpolate with the shell, you can use a backslash to disable the character immediately following it, and causing it to not be interpreted by the shell. Or if you know that you don't have any variables or meta characters that you want to expand or interpolate, but you want to use them in a command, you can use single quotes, which disables all of the meta characters within the command. And then there are also back quotes. Back quotes would be on your keyboard. If you look right next to your number 1 key above the tab in the corner there, there's the key that if you hit Shift, it's a tilde, and if you don't hit Shift, it's a back quote. And if you use back quotes, the shell will execute whatever is in that, in between the back quotes, and return the value to you. And that's used a lot in say, shell programming, in that to set a value based on the output of a command. And I include here, in modern shell programming, it's considered a better practice to use a variable interpolation version of that. So instead of the back quotes to run the command, you would use $ and then parentheses, and then put your command line between the parentheses and use that to return the value rather than the back quotes. So let's look at some of the ways that quoting works. So if I type ls, as we're looking at, l star, that shows me all of the files that start with L, because it expands the star as a glob character and shows me everything that matches. However, if I typed ls-al and then I'd use double quotes, L star, it's actually not going to expand the star, and it's going to treat that as a regular character and try to show me any commands with the name L and the star character, which of course there are none, because that would be a pretty difficult command to run. But you can see that, like, say I type echo and then /path, or the path variable, but I enclose it in the quotes, variables are still expanded by the shell, even in double quotes, so it's going to echo the full path. To fix that, if you're using double quotes and you want to echo the name of a variable with the $, but you don't want to expand it, you can use the backslash to escape the $, which means that the shell won't interpret it as a variable, and it will just echo $path for me. Now, single quotes, on the other hand, turn off all meta characters, and so variable expansion doesn't work, and the globbing doesn't work. So ls-al, and then single quotes L star, of course, returns no such file. The single quotes and double quotes both turn off the star, but unlike the shell variable with the double quotes, I can do echo path, $path in single quotes, and I don't have to use the backslash to escape the $, because the single quotes escape all, turn off all meta characters. And then the backslash, or the back quotes work. They execute the command and return the output. And where this comes in really handy is for something like setting a variable. So I could do p, let's say, make sure I don't have an alias set to that. I do. So let's say x equals, and then back quote, echo path. And the back quotes do expand variables and special characters and all that. So x should be set to the value of my path environment variable. So now if I do echo x, if I typed echo correctly, if I type echo x, or $x, I get the same value as the path, because the echo command, the value of running that command gets set to the environment variable, not environment, to the shell variable x. So all of these variables and environment variables and the ability to set them and run commands and get their values and all that is really, setting you up for writing shell scripts. And shell scripts at heart are really just setting setting shell variables and doing things with them and running commands just as you would sitting at a shell prompt and running them one at a time manually. And you can do, even very simple shell scripts can be done just from the command line. And the shell has control statements that you can use in the scripting, but you can also use directly at the command line as well. So if you want to run a couple commands in sequence, or you want to run a couple commands and you want the first one to run and then the second one to run if the first one ran successfully, or the second one to run if the first one didn't run successfully, you can use these control statements or control special characters to do that. So the semicolon character is special to the shell in that it separates commands. So if you run a command and then use a semicolon and then another command, the semicolon separates the two commands as far as the shell is concerned, and it will run each command or you could just keep that going, and it'll run each of those commands in sequence. Now, if you want to run a command and then have another command run if the first one succeeded, you would use the double ampersand statement, control characters, not really control character, but the double ampersands as a control statement, and that's a logical AND. So if the first command finishes with a success value or a true value, then the second command will run. Alternatively, you could use the double pipe character, and that's a logical OR. So it'll run the first command, and if that command doesn't run successfully or is false, then the second command will run. So some simple examples of that to show how that might work, and you could do some basic shell-like scripting just on a simple command line. Say I wanted to cd to a directory and then do something, we'll do something really simple that you would necessarily have to do this way, but I could cd to var log and then do an ls-al and look at the contents of the directory, and then cd back to my home directory, and then say print pwd for print working directory to say where I'm at. So I made those 4 steps. However, if I didn't want to type and then wait and then type and then wait, I could run them all at once in sequence by doing them all in sequence and separating them with a semicolon. So I could do cd var log, then ls-al, then cd to go back to my home directory, and then pwd to see where I'm at. So it's run all of them in sequence. And you can see the result of the pwd command and show you that I'm back in the home directory. Now the disadvantage of, in some cases, of running the commands in sequence like this is that if you're doing something like that where you're expecting to change to a different directory and then remove some files and then change back, that sort of thing, if the first command before the semicolon to change to the directory where you want to remove files was not successful, the second part of the command, the removing of, say any number of files, will run anyway, which means that, say you wanted to change to a log directory and remove all the files in it. So you did, cd to var log something, and then a semicolon and rm star. If that first part, the cd command, didn't work, say you typoed the path to the log directory, the shell will run that, and then in sequence run the next command, which means that whatever directory you're in is where it will run the rm star. So you could wind up deleting files that you didn't intend to because the first part didn't work. Not to say that it's bad to use the semicolons to separate commands. In some cases it's perfectly valid and the best way to do it, but it is something to be aware of, that it will run the commands in sequence no matter if they succeed or not, and if you're expecting to be at a point in the file system where you're not, or something like that, it would be better to do it a different way. So let's look at those ways. So the shells have some built-ins called for true and false, just for generally used for testing. So if I run the command true and then echo $? Which gives me the return code from the last command run. See, true had a return code of 0, which is success as far as the shell is concerned. So if I run the false command and then echo $? to look at the return code from that, I get a 1, and 1 is false as far as the shell is concerned. So I could do something like, not a great example, but to show you how that would work, if I run true and then use the 2 ampersands for the logical AND, and then ls-al. True returns a success value, and so the ls command runs. Now if I run false, and the 2 ampersands for the logical AND, and ls-al, the ls command does not run because false returns a not successful command. So if I change the operator I'm using there, if I run true or ls-al, in this case the ls doesn't run because the true command returned a success value, and so the shell is done. True was successful, so it doesn't run the ls command. On the other hand, if I do false or ls-al, false returns a value that is not a success value, and so then the ls command runs because it's an OR. So those are some more of the basics of working on the command line and using the shell. The reading for this week is Chapter 3, which is a chapter called The Utilities in the Practical Guide to Linux Command Editors and Shell Programming book. And that will go into more detail on the more common command line utilities that you'll be using on a Linux system. And it's very important to read that. A lot of that is covered in the quiz and the assignment. And of course, there's a quiz and the assignment. The assignment is set up basically the same as last week. Use the script command at your Unix shell prompt, your Linux shell prompt, to record your session, and there's a list of short list of tasks to do in the shell, and it's not like do this exactly. It's do this for me, and you'll need to know what I've talked about here and do the reading to know what to do with those steps. And I've also included an extra credit question on this assignment. So take a look at that, and then both the quiz and the assignment, as always, are due by 12:01 a.m. Next Monday, and I will talk to you next week.